A National Electrical Code, or NEC, strictly prohibits tapping into a 100 amp safety disconnect to supply a 30 amp circuit without proper overcurrent protection. The core principle here is conductor protection. Conductors, or wires, must be protected against overcurrents to prevent overheating, insulation damage, and potential fire hazards. The NEC mandates that conductors be protected by an overcurrent device such as a circuit breaker or fuse, rated no higher than the ampacity of the conductor. In other words, the overcurrent device must trip or blow before the conductor is subjected to a current that exceeds its safe carrying capacity. In this scenario, the 100 amp safety disconnect serves to protect the 100 amp service conductors feeding it. It's designed to interrupt the entire 100 amp service if an overcurrent condition arises on that main service. However, it does not provide adequate protection for the downstream 30 amp conductors that will be supplying the specific piece of equipment. If a fault or overcurrent situation occurs in the 30 amp circuit, the 100 amp disconnect will not trip until the current exceeds 100 amps. This means the 30 amp conductors could be subjected to current far exceeding their ampacity for an extended period, leading to potential overheating and damage before the 100 amp disconnect finally interrupts the circuit. To comply with the NEC and ensure safety, you must install a dedicated overcurrent device, either a circuit breaker or fuse, rated to 30 amps or less, at the point where the 30 amp conductors tap off from the 100 amp service. This 30 amp overcurrent device will provide the necessary protection for the 30 amp conductors, interrupting the circuit if an overcurrent condition occurs specifically within that 30 amp branch. The maximum current that the 30 amp circuit can handle is to be able to protect them or avoid any dangerous situation or condition. The length of the run, approximately 25 feet, between the safety disconnect and the 30 amp circuit breaker does not negate the requirement for overcurrent protection. The NEC mandates overcurrent protection regardless of the conductor length. Consider the practical implications of not providing proper overcurrent protection. Firstly, imagine a short circuit developing in the 30 amp equipment. Without a 30 amp breaker or fuse, the short circuit current, potentially far exceeding 30 amps, would flow unimpeded through the 30 amp conductors. This could cause the conductors to overheat rapidly, melting the insulation and potentially igniting surrounding materials. Secondly, an overload situation, where the 30 amp equipment draws more than its rated current but not enough to trip the 100 amp disconnect, could also damage the 30 amp conductors over time. The sustained excessive current would gradually degrade the insulation, reducing the conductor's lifespan and increasing the risk of failure. Now let's delve into specific NEC articles that reinforce this requirement. While the exact article number may vary depending on the edition of the NEC, the general principles remain consistent. Firstly, NEC Article 240.4, Protection of Conductors, is the primary article addressing overcurrent protection for conductors. It states that conductors shall be protected against overcurrent in accordance with their ampacities. Secondly, NEC Article 240.21, Location and Circuit, discusses the placement of overcurrent protection devices. It generally requires that overcurrent devices be located at the point where the conductors receive their supply. This means the 30 amp overcurrent device should be placed where the 30 amp conductors tap off from the 100 amp service. Thirdly, NEC Article 310.15, Ampacity of Conductors, provides guidelines for determining the ampacity or current carrying capacity of conductors. This article helps you select the appropriate conductor size for the 30 amp circuit, ensuring it can safely handle the intended load. When selecting the 30 amp overcurrent device, ensure it is properly rated for the voltage and interrupting rating required for the application. The voltage rating must be equal to or greater than the system voltage, and the interrupting rating must be sufficient to safely interrupt the maximum available fault current at that location. Installing a 30 amp circuit breaker is generally straightforward. Firstly, mount the circuit breaker in a suitable enclosure, such as a panel board or a junction box. Secondly, connect the 30 amp conductors from the 100 amp safety disconnect to the line side terminals of the circuit breaker. Thirdly, connect the conductors that will supply the 30 amp equipment to the load side terminals of the circuit breaker. Always follow the manufacturer's instructions for proper installation and torque specifications. Installing a 30 amp fuse involves similar steps. Firstly, mount a fuse holder in a suitable enclosure. Secondly, connect the 30 amp conductors from the 100 amp safety disconnect to one side of the fuse holder. Thirdly, connect the conductors that will supply the 30 amp equipment to the other side of the fuse holder. Fourthly, insert a 30 amp fuse into the fuse holder. Again, always follow the manufacturer's instructions for proper installation. Remember to always de-energize the 100 amp safety disconnect before working on any electrical connections. Verify that the power is off using a reliable voltage tester. Working on live electrical circuits can be extremely dangerous and potentially fatal. Consider also the implications for future modifications or additions to the electrical system. By installing a dedicated 30 amp circuit breaker or fuse for the 30 amp equipment, you are creating a separate, protected circuit that can be easily expanded or modified in the future without affecting the rest of the system. This provides flexibility and simplifies future maintenance or upgrades. In summary, tapping into a 100 amp safety disconnect without fusing to protect 30 amp conductors is a violation of the NEC and poses a significant safety risk. The NEC mandates overcurrent protection for conductors based on their ampacity, and the 100 amp disconnect does not provide adequate protection for the 30 amp conductors. Install a dedicated 30 amp circuit breaker or fuse at the point where the 30 amp conductors tap off from the 100 amp service to ensure compliance with the NEC and protect against overcurrents. Prioritizing safety and adhering to the NEC is crucial when working with electrical systems. Proper overcurrent protection is a fundamental aspect of electrical safety, protecting conductors, equipment, and personnel from potential hazards.